So hello everyone, in this video lecture we will discuss about the numerical integration. Numerical integration. What do you mean by numerical integration? Whenever we are not able to find integration by the classical techniques, then we'll use numerical integration. Suppose we have to find out integration of the function e raised to a minus x square sin x. So it is not easy to compute. It is not integrable, we can say. Or we will find out log x dx, integration of the function sin x log x upon under x square plus cos x. There are lot many functions, those are not integrable. So in that case, whenever we are not able to integrate a function, then we'll use numerical integration. Numerical integration is possible whenever we have to do definite integral. Okay. So definite integral is what? Definite integral of a continuous function f of t over the interval ab is the area under the curve. Suppose we are talking about a function, that the function is like that, then definite integral is what? A to b ft dt, this is the function ft. Okay. Then the area under the curve, this is the definite integral. Definite integral of the function. So this is, so the best way to calculate definite integral, according to fundamental theorem of calculus, What is fundamental theorem of calculus? Fundamental theorem of calculus is what? Fx is a continuous function that's always small letter. Fundamental theorem calculus is what? Let fx be a continuous function on the interval ab, and assume that fx is an antiderivative of fx. The definite integral which gives the area under the curve of fx between a and b satisfy the following formula. What is that formula? A to b fx dx equal to f of b minus f of a. So fx is a continuous function on the interval ab, and assume that this fx, it is the antiderivative of the function fx. Then the definite integral which gives, so this definite integral is what? That is giving the area of a function under the curve so this is a to b between a and b satisfy the following formula. What is that formula? Integration of the function fx dx from a to b is equivalent to f of b minus f of a. F of b is what? That is f is what? That is the antiderivative of the function fx. Okay. So this is the fundamental theorem of calculus. So the best way to compute definite integral according to fundamental theorem of calculus is what? Use the antiderivative that is a function f with f dash equal to f such that a to b f of t dt equal to f of b minus f of a. So this is the definite integral according to the calculus fundamental theorem of calculus. So suppose we have to integrate this function fx, and if we know the antiderivative of the function, then we can write directly the antiderivative f at the upper limit minus antiderivative of the function f at the lower limit. So this is according to fundamental theorem of calculus. But the problem is what? Antiderivative, but the antiderivative of all the function doesn't exist. Okay. So suppose you have to compute the integration of the function ex square dx a to b. So e raised to power minus x square does not have antiderivative. So we cannot apply antiderivative. So we cannot apply fundamental theorem of calculus. Theorem of calculus. So when this is the situation, then we have to think about the numerical integration. Okay. So what is numerical integration? Whenever, like, why we have to do numerical integration? When the antiderivative of the function doesn't exist. So the problem is what? Problem is with the function. So if we are able to approximate this function with the help of any other function and that is integrable, then we can say, then we can compute the integration. Okay. So in this particular chapter, we'll discuss how to approximate this function with the help of some other function so that we can do integration, or we can get some formula to find the integration of the function. Okay. So as we have discussed in the previous chapter, interpolation chapter, any continuous function can be approximated inside the interval AB by the polynomial. Okay. Why polynomial? Because polynomials are continuous and differentiable. And according to Weierstrass theorem, any continuous function can be approximated by the polynomial. So that is the reason. So we'll use interpolating polynomial, interpolating polynomial to approximate a continuous function f(x). Why? Because as we have already discussed in the previous chapter. So also there's some point, polynomial provides nice, smooth functions for approximation. As we have discussed in the previous chapter also, we can also use Taylor series to approximate a function. But the problem with the Taylor series is what? That gives approximation about a point only. As we go away from the point, then it will not give a good approximation. So that's why we generally use interpolating polynomial. Okay. Because we are required a polynomial that should be valid for the whole interval. So I am not writing that point, it should be clear. Okay. So now the methodology. Approximate function f over the interval ab using polynomial, using some polynomials. What polynomial? It could be any, like suppose Lagrange polynomial, as we have done in the previous chapter, Lagrange polynomial and Newton divided difference forward or backward. It's your choice, you can use any of the polynomials. So by some polynomial, maybe Lagrange, Newton forward, backward or divided difference. Any polynomial, but we are interested in Lagrange polynomial. So what is the methodology? Any function f(x) can be approximated by the polynomial, and according to Weierstrass theorem we are having some error also. That error is small, then we can say the polynomial is best approximating the function f(x). Okay, so whenever we will integrate f(x) from a to b, then it will integrate there. This e means what? That is error. A to b. How to find out polynomials, that we have already discussed in the previous chapter, but let us find out this polynomial. Okay, suppose that n plus 1 data points are available so we can find out Lagrange polynomial. I am using Lagrange, that's why Lagrange polynomial. Other polynomials can also be find out. Lagrange polynomial or Lagrange interpolating polynomial. Interpolating polynomial p and x. Maximum, if there are n plus 1 data point, then maximum degree polynomial that is passes through n plus 1 data point is what? p and x, that is n degree polynomial. So suppose x0, fx0, x1, fx1, xn, fxn, and plus 1 data points are available. Okay, so n degree polynomial is equivalent to what? Lix f of xi, I equal to 0 to n, where Lix is what? That is x minus x0, x minus x1, x minus xi minus 1, x minus xi plus 1, x minus xn upon xi minus x0, xi minus x1, xi minus xi minus 1, xi minus xi plus 1, xi minus xn. Okay, Lix, that means xi term will not be in the numerator, and all element will be subtracted by xi in the denominator. Okay, so when we'll integrate a to b fx dx, it is equivalent to, or approximately equivalent to, a to b p n x dx plus a to b, or error term will write let all, equivalent to summation Lix f of xi, I equal to 0 to n a to b. Okay, this can be written as summation Lix a to b f of, since this Lix, this is depending on the value of x, and fxi, these are the constant values, so we can write it as outside the integration, and here you are having Lix dx. This Lix we can choose as wi weight. So this integration can be written as summation wi f of xi, I equal to 0 to n. So this integration a to b fx dx equal to wi summation of wi f of xi, where wi is what? A to b Lix dx. Okay, what about the error term? Error will be, what is the error in Lagrange interpolating polynomial? X minus x0, x minus x1, x minus xn upon factorial n plus 1 f n plus 1 c x dx a to b. This is the error term. Okay. So now come, n is what? N is the number of data points are available. Now we'll derive this integration formula for n equal to 1. Now take the case when n equal to 1. n equal to 1 means what? Available data points are x0, fx0 and x1, fx1. That means if we are we'll understand it geometrically. So what does it imply? That suppose there is some function, this is a to b, this is the function fx. So this is what? This is your point x0 and this is the point x1, x0 as a. Okay, this ordinate is fx0, this is fx1. Okay, so the data points are available here, x0, fx0 and x1, fx1. Then we can approximate it. This is the function fx. We are approximating it by a straight line. Okay, so we are approximating this region by a straight line. This is straight line. Okay, so now we are taking the case n equal to 1. N equal to 1, that means the function a to b fx dx can be written as summation I equal to 0 to 1 wi f of xi. Okay, wi is what? That is w0 and w1. w0 means what? That is a to b. A to b L0x dx, and w1 is a to b L1x dx. So L0x is what in this case? X minus x1. Only the two data points are available, or when you have to compute L0x, that is x minus x1 upon x0 minus x1, and L1x is what? X minus x0 upon x minus x1 minus x0. Okay, just put the value of L0 and L1, compute the value of W0 and W1. Just keep in mind the distance between A and B we are assuming as h. Okay, so x1 minus x0 equal to h, or b minus a equal to h, same value. Okay, so just keep in mind. Let us we have assumed this. Okay, now compute the value of W0, W1. So W0, W1 is what? X minus x1 upon x0 minus x1 dx a to b. The value is coming out to be x minus x1 whole square upon 2 minus h. Limit is what? From a to b. Okay, just keep in mind a equal to x0, b equal to x1. The value is coming out to be h upon 2. Similarly, we can compute the value of w1, that is also coming out to be h by 2. Where h is what? That is b minus a and x1 minus x0. Okay, so what we compute? We have computed here a to b fx dx equivalent to the value of w0, that is h by 2 f of x0 plus the value of w1 h by 2 f of x1. So this can be written as h by 2 fx0 is what? F of a plus f of b. This integration is converted into the summation of fa and fb multiplied by h by 2. Okay, so this is the integration we obtained whenever n equal to 1. That means the domain is divided into only one part. So this is called trapezoidal rule. Trapezoidal rule. Why trapezoidal rule? Because geometrically it is the area of the trapezium. Trapezium with h and ordinates f of a and f of b. If you go back, then you can see from here the ordinate is what? F of a, f of b, and this is what? H is width of these two parallel. So If you compare with the trapezium, what is the area of the trapezium? Sorry. If you see, suppose this is a trapezium. And this is suppose H. This is the length B. This is A. This is suppose C. And it is D. Then area of trapezium is what? A plus B upon 2 into H. This is area of the trapezium. It is similar to this figure. This is f of A, this is f of B, and this is showing like a trapezium, and the width is what? H. That's why. Okay. So that's why it is called trapezoidal rule. Trapezoidal rule. Now we are taking the case when n equal to 2. N equal to 2, that means we are taking available data as x0 fx0, x1 fx1, x2 fx2. Now 3 points are available. 3 data points are available. 3 data points are available. When this is the situation, then 2-degree polynomial is possible, that is passing through these 3 data points. Okay, so let us understand what is the situation. Suppose we are having a curve, something like that. So what is possible? We are taking this figure. So second degree polynomial is possible, that means this is the quadratic polynomial P2x. This is the function f. So area under the curve will be what? This is the area. But we are approximating it with the polynomial. So this part and this part will be the error part. Only when we are approximating this function fx, this is the function fx with the help of P2x. So the area under the region is what? Only this portion. This and this part is not coming inside the integration, like when we are approximating it with the help of polynomial. So P2x dx. Okay, so this is the P2x. So this and this part will give you the error because it is not covered by the polynomial. Fx is approximating by the polynomial P2x. Okay, so only this reason is completed. So we are getting error here. How much error? This is incorporating inside the polynomial and it is deducted. So that's why we are getting some error. Okay. So this P2x will be what? P2x, it is equal to summation wi f of xi I equal to 0 to 2. W0 will be what in this case? L of 0x dx a to b. A is x0, b equal to x1. That should be clear as it is similar to the previous case. Okay, now we are having 3 points. What are the 3 points? This is x0, this is x1, this is x2. Okay, so we have divided this interval x0 a to b into 2 subintervals, this and this. Just keep in mind these are equal in length. These subintervals are equal in length. That means x2 minus x1 equal to x1 minus x0 equal to h. So h will be what? We can say this is the value a, this is a, x2 is b and x0 is a. So that is what? B minus a upon 2. Length of the interval is what? B minus a, and h will be what? That is the half of the length of the interval, b minus a upon 2. Okay, and the midpoint x1 can be written as a midpoint of the interval, so a plus b upon 2. So whenever we are computing x0, w0, that is what? x0 to x2, x0 to x2. So what would be the value of this L0x? So x0 to x2, L0x means what? x0 will not be in the numerator, so x minus x1, x minus x2 upon x0 minus x1, x0 minus x2 dx. This is the value of w0. When we'll integrate it, it is coming out to be h upon 3. h upon 3. Now compute w1. w1 is what? L1x dx a to b x minus x0, x minus x2. x1 is not with the numerator. x1 minus x0, L1, x1 minus x0, x1 minus x2 dx, x0 to x2. The integration value is coming out to be 4h upon 3. It should be clear. That is b minus a upon 2. This is w1. And w2 is coming out to be again h by 3, or it is x0 to x2. I'll write formula so you can compute by yourself and check the value. x2 minus x0, x2 minus x2. Okay. The value is coming out to be h upon 3. So the value of w0 is h upon 3. It is equivalent to w2, and w1 is coming out to be 4h upon 3. Put all these values into the formula. fxi I equal to 0 to 2. So h upon 3 fx0 4h upon 3 fx1 plus h upon 3 okay. That can be written as h upon 3 f of x0 plus 4 f of x1 plus f of x2. This is the integration a to b fx dx. Or we can write it h upon 3 f of a plus 4 f of a plus b upon 2 x1 is midpoint plus f of b. So this is called Simpson one-third rule. Simpson derived this formula, so it is called Simpson one-third rule. So this integration is equivalent to this one. Now let us discuss about error, or let's do some example based on it, then it will be good to understand method properly. Let us take simple example. Suppose you have to integrate 1 to 1.2 1 upon x dx. Integrate it with the help of trapezoidal rule and Simpson one-third rule. Okay, so function is what here? F of x is 1 upon x. If we are applying trapezoidal rule, so x0 is what, or I should write a is what, that is the first lower limit of the integration, that is 1, and b is what, that is 1.2. If we will apply trapezoidal rule, okay, let's do in the next page. Trapezoidal rule. Trapezoidal rule is what? H upon 2 f of a plus f of b. Okay, so 1 to 1.2 1 upon x dx. So h is what here? B minus a. In trapezoidal rule, it is b minus a. So 1.2 minus 1, it is 0.2. Okay, a is what? That is the lower limit. B is what? That is the upper limit, 1.2. And function is what? That is 1 upon x. So f of a. F of a is what? F of 1, it is 1 upon 1. F of b is what? F of 1.2, it is 1 upon 1.2. Okay, so this integration 1 to 1.2 1 upon x dx, it is equivalent to b minus a 0.2 upon 2, that means 1 plus 1 upon 1.2. This is the integration. This integration is coming out to be, you can compute it, the value is coming out to be 0.183. So this is the integration by trapezoidal rule. Now by Simpson one-third rule. Simpson one-third rule. A equal to what? That is 1. B equal to what? 1.2 and midpoint. A plus B upon 2 is what? That is 1 plus 1.2 upon 2. That is 2.2 upon 2. That is 1.1. So what is Simpson one-third rule? A to B fx dx equal to h upon 3 f of a plus 4 f of a plus b upon 2 plus f of b. H is what? That is, now compute h. What is h? In Simpson one-third rule, that is b minus a upon 2. B is what? That is 1.2 minus a is what? 1 upon 2. This is 0.1. In the previous case, it was only b minus a. Just put the values 0.1 upon 3. F of a, that is f of 1 plus 4, f of 1.1 plus f of 1.2. 0.1 upon 3. F of 1 is what? That is 1 plus 4 into 1 upon 1.1 plus 1 upon 1.2. You can compute this result. That will be the integration of the function inside the interval 1 to 1.2 by the Simpson one-third rule. What is the difference between these two methods? Simpson one-third rule is much better than the trapezoidal rule in terms of accuracy. How? That we'll discuss with the help of error. Help of error. What is error? Before that, I just want to write one theorem statement, that is weighted mean value theorem. Weighted mean value theorem. Weighted mean value theorem. What is weighted mean value theorem? Suppose a function f belonging to the interval C a to b, then the Riemann integral of G exists on AB and Gx does not change sign on the interval a to b, then there exists a number C in the open interval AB with a to b fx dx fx gx dx, that means the multiplication of two functions fx and gx, that is equivalent to f of c a to b gx dx. That means what is weighted mean value theorem? If the function f is continuous and differentiable inside the interval ab, then the Riemann integral of g exists. Riemann integral of g exists on the interval ab, and gx does not change sign. That means the function gx is not changing sign in the interval ab. That means gx is having same sign throughout the interval ab. Then there exists a number c inside the open interval such that this integration is equivalent to f of c ab gx dx. This theorem we are going to use to derive error formula for the trapezoidal rule and Simpson one-third rule. Now, error for trapezoidal rule. Trapezoidal rule. What is the error formula for trapezoidal rule? A to b fx dx equal to, I told you, like a to b pnx dx plus error. A to b. What is error in Lagrange interpolating polynomial? That error will be integrated by from a to b, that will be the error in the integration whatever we are computing with the help of Lagrange interpolating polynomial. So what would be the error? That will be a to b, so I should write in term of smaller so there will not be any confusion, x minus for n equal to 1. Now take the case when n equal to 1. Okay, so n equal to 1, that means you are having x0 and x1 data points. So what would be the value of this error in Lagrange interpolating polynomial? That is x minus x0 x minus x1 upon factorial to f to cx dx. Okay, so this is the error whenever we are using 1 degree Lagrange polynomial to approximate this function. Okay, so error will be what? X minus x0 x minus x1 f double dash cx upon factorial 2. So let us treat it as a function gx and this is a function as fx in weighted mean value theorem. Weighted mean value theorem. Okay, so let's compare this formula with the weighted mean value theorem. Let us suppose gx is what? X minus x0 x minus x1 the polynomial. Okay, and fx we are taking as f double dash derivative dx in mean value theorem, weighted mean value theorem. What is weighted mean value theorem? If gx does not change sign inside the interval ab. If we see the interval is what? That is a to b. Okay, if we are putting gx is what? X minus x0 x minus x1. If we are taking any value xi inside the interval a to b, suppose any point inside a, so gx does not change sign in AB. That means take suppose some value in between a to b. Okay, then x suppose we are taking here. So x minus a will be what? X0 is what? That is your a. So x minus a, it will always be positive, and x minus b will be what? It will be x is greater less than b, so it will be negative. So gx does not change sign in ab. Any point you take inside the interval, that means gx is negative throughout the interval ab. So we can apply weighted mean value theorem. If this is the case, if you go back, if gx does not change sign inside the interval ab, then there exists a number c in ab such that this integration, multiplication of two function, integration is equivalent to f of c into g of x dx inside the integration. So gx does not change sign inside the interval ab, so we can write this integration as x minus x0, x minus x1 f double dash dx upon factorial to a to b is equivalent to f double dash c. Okay, let us take this point as what? That is r. We are taking this point as r. R is what? That is belonging to the interval a to b as per the weighted mean value theorem. X minus x0, x minus x1 dx a to b. Now integrate this polynomial, because what problem we were facing to integrate this term, because f double dash, that is also the function of c is the function of x, and this is a polynomial. We cannot integrate this function with this polynomial because function f double dash is unknown. So that's why we have used weighted mean value theorem to get this term outside. Okay, so f double dash dx, so we are replacing it by r. R is what? That is belonging to the interval ab by weighted mean value theorem. It is applicable whenever the gx function does not change sign inside the interval. Weighted mean value theorem. So what we are getting this as f double dash r, and integration of this function is what? This is coming out to be x minus x0, x minus x1, that is the integration is coming out to be h cube